In this video tutorial today, we will find the impounded reservoir capacity or service reservoir or balancing reservoir capacity. First of all, I request you to watch this video as you are the student of water supply in engineering. To calculate the volume, we use the basic formula, that is volume of or capacity of impounded reservoir equals to total sum of deficit or the maximum cumulative surplus plus maximum cumulative deficit. In mass curve, the second formula is used graphically, that is the capacity of reservoir equals to peak cumulative surplus plus peak cumulative deficit. Now, deficit and surplus means if the inflow minus outflow is positive, it is surplus. If inflow minus outflow is negative, it is deficit. And inflow is also called supply and outflow is demand. In this question, we have the month January to December and the inflow rate for the given month and the demand, that is 6,000 million liter per month. Here inflow is given in meter cube per second and outflow in per month million liter. So in this question we have to calculate the inflow in million liter. So to calculate it, we should know the number of days in every month. If it is hard to remember the number of days in month, then we use average number of days in 1 month. That is average number of days in 1 month equals to 365 divided by 12 is equal to 30.42 days. But here the exact number of days are used. We can use 30.42 days in each month in average also for the calculation. So in this question, the main thing is to calculate the volume equals to summation of deficits. Deficit equals to inflow minus outflow, and inflow is in million meter cube per second. So million in million liter per month. We have to convert this into million liter in per month. So for the conversion, meter cube percent for number one, 2.9 meter cube per second in 1 day into 86400 1 day into, it is in meter cube, into 10 to the power 3 in liter and into 10 to the power minus 6 million liter and into 31 days equals to 7767.36. Similarly, use 2 into 86400 into 28 days into 10 to the power 3 into 10 to the power minus 6 per million is equal to 4838.4. Similarly, for next 1 into 1 meter cube per second into 86400 into 31 days, 31 31 days into 10 to the power 3 liter into 10 to the power minus 6 million liter per month is equal to 2678 minus 4. And again for the next, we have 0.2 into 30 days, 0.2 into 30 days into 86400 into 10 power 3 into 10 power minus 6 equal to 518.4. Only change next 0.2, 0.5 and 0.5 and 31 other are same, that is 0.5 into 31 days into 8640 into 10 to power 3 into 10 power minus 6, 1339.2. Similarly change 0.5 to 1 and number of days 30 in place of 31 in, and other are same. Similarly 2592 million liter in 1 month. Again 2 into 31, 2 into 31, 5356.8, 2 into 31, 3 into 31, 3 into 31. I have only changing the meter cube per second values and number of days values in enter data. Other 8640 into 10 power 3 into 10 power minus 6 are same in calculator. it becomes 8035.2. Similarly, 31 into 3, 4 into 30, 4 into 30, 10368, 5 into 31, 5 into 31, 13392. Again, 5 into 31, 4 into 30. Okay, in this way 10368. All the data in million liter inflow are calculated. Outflow are is given 6000 million liter per month in all month. So surplus means inflow minus outflow. Surplus in first 7767 minus 6000, it is positive. 4838 minus 6000, negative. Deficit 2678 minus again deficit, again deficit, again deficit, deficit in 8035.2 minus 6000, this is 2035.2, positive, that is surplus. Similarly all are calculated, and the here summation of surplus is greater than summation of deficit. For the reservoir storage, surplus should be greater, that is supply should be greater than demand. Supply should meet the demand, otherwise the reservoir capacity cannot be obtained because there is no sufficient supply for the reservoir. So here the project is feasible as surplus is greater than deficit, and the volume of the reservoir, capacity of reservoir equals to total sum of deficit equals to 18676.8 million liter. Now moving to the mass curve method. Here all are same. This million liter are same. Cumulative inflow and cumulative outflow are calculated, and the cumulative inflow means 7767.36 plus 4838.4 equals to 1260.5.76 plus 2678.4 equals to 1528.4.16 plus 500.4 equals to 1580.2.56. Similarly, cumulative outflow equals to 6000 plus 6012 plus 618,000 plus 625,000 million liter, and this cumulative inflow and cumulative outflow are plotted in graph for January, February to December. The cumulative outflow is linear curve and inflow curve is not linear, and there is maximum deficit means cumulative deficit, maximum cumulative deficit and maximum cumulative surplus. 7767 minus 6000 positive, 12605.76 minus 12605.76 here, 7767.36 6000 1767, but here in 7528.96 72000 3288.96, this is maximum surplus, that is cumulative maximum surplus, that is also shown in curve, and this plus cumulative maximum deficit means where 25090 minus 4200, 25090 minus 0.56 minus 42000, yes, here is 16909.44, and in 1973 733.76 minus 3600 deficit 16 to 66. Maximum is 25 25090.56 minus 42000, this is 16909.44, that is cumulative maximum deficit occurs at that point, at this point, that is at month of July. In curve we have to plot this curve like that: January, February, March, April, May, June, July, August. Check in August. 33,125,48,000 minus 33,125.76. 14874. No. In the month of July, the peak is 16909 point something. This value, maximum cumulative maximum deficit, this value and maximum cumulative surplus is added to know the capacity. This is equal to 3288 point in this maximum cumulative surplus, 3288.96 plus 16909 is equal to 20197.96 million liter. By using mass curve we calculated the volume of the reservoir is 20197.96. Now in balancing reservoir, that is balancing reservoir is only the reservoir where the supply and demand are equal, that is inflow and outflow are equal. So in question the 2 millions people under 60 LPCD, so the total demand is 2 million into 160 is 320 million liter. Okay, 320 million liter per day is demand equals to 320 million liter per day, and the consumption pattern is continuous type, means full 24 hour and all 24 hour is there is the outflow for 24 hour and inflow for all 24 hour, that is 5 to 7 means 2 hour, 2 hour, 7 to 11, 7 to 12, 5 hour, 12 to 17, 5 hour, both in outflow and inflow. inflow is also that is supply for 24 hours and demand for 24 hours. In this type of questions, inflow and outflow are continuous. So for the calculation of the supply, we use this 320 million liter per day. 320 million liter per day is given in per hour. So 320 divided by 24 into 2. Here calculation, I show the calculation, that is the consumption percentage. Here consumption percentage is given and the outflow or demand is continuous, that is outflow is continuous type 24 hours. So we use this consumption percentage to calculate the discharge in million liter, that is outflow in million liter for the given time period. Now I will show in this inflow time 2 hours. Inflow rate is 320 million liter per day. One day is 24 hours. 320 divided by 24 into 2 equals to 26.67. Similarly, 320 divided by 24 into 5 equal to 66.67. 66.67. 26.67. 320 divided by 24 into 10 equals to 133.33. Total inflow is 320 million liter total sum in one day. This inflow and outflow is equal. So this is the reservoir called balancing reservoir. So for the balancing reservoir, first we have to calculate the capacity is the calculation of inflow and outflow and cumulative inflow, cumulative outflow, and maximum cumulative deficit plus maximum cumulative surplus. So for the given interval of time, we calculate the inflow in million liter, that is 320 million liter per day. In 5 to 7 2 hour, 320 divided by 24 into 2. Similarly other, and in case of this outflow, 320 divided by 24 into 2 is not used because the consumption percentage is given. For the continuous inflow and continuous outflow, demand both supply and demand continuous, we use the consumption percentage. 25% is consumed in this 5 to 7, that is total 320 million liter. Okay, in 24 hours, all hours is 24. 24 hours, 320 320 million liter in 24 hours, and it's 25% means 320 into 0.25 is equals to 80. Okay, similarly 30% of 320 is 320 into 0.3 equals to 96. 320 into 0.15 equals to 48. 320 into 0.2 equals to 64. 320 into 0.10 equals to 32. Here outflow is calculated. So cumulative inflow, cumulative outflow, and cumulative inflow minus outflow deficit 53, 82, 64, 101.338. So maximum cumulative deficit is 101.338 plus cumulative maximum cumulative surplus 0 is the capacity of the reservoir. So size of the balancing reservoir equals to 101.338 for the continuous type of inflow and outflow, that is supply and demand continuous. For this, the inflow is calculated by using 320 million liter per day. 320 divided by 24 into 2 into 5 into 5 into 2 into 10. In outflow, 320 into 0.25, 320 into 0.30, 320 into 0.15. That is in 24 hours. 24 hours supply. Similarly, in this next question, same question, but the what is supply is continuous. Supply is same before, like that before, but demand is intermittent. That is 5 to 7 in morning and 16 to 18. 5 to 7 2 hour, 16 to 18 2 hours. 16 to 18 means here in this 2 hour. 16 to 18 means here. 12 to 17 means 16 to 17 1 hour. 17 to 18 1 hour outflow. In this question, the demand is not continuous. Demand is intermittent type. So outflow is calculated. Total 320 million liter in one day divided by 24 into 2, 26.67. No, the demand is not supplied by 24 hours. Here only 4 hours is used to outflow. 4 hour outflow is only given. No full 24-hour outflow or 24-hour demand here. So here for the calculation we use 320 liter in 4 hours. 320 million liter in 4 hours divided by 4 into 2, 160 into 1, 80 into 1, 80. But in before, the continuous outflow 24 hours outflow is given, so we use the percentage consumption for that calculation. But in this question, 24-hour supply, no, 24-hour demand is not here, intermittent type of outflow. So 320 million liter is the total demand in one day. 320 in one day means in 24 hours, but the demand is only given to 4 hours. So 320 divided by 4 into 2, 320 divided by 4 into 1, 320 divided by 4 into 1 is outflow. Inflow is same. 320 divided by 24 into 2, 320 divided by 24 into 5, 320 divided by 24 into 5. Similarly, 24 into 2 divided by 24 into 10. Like that in this question. Also, if the outflow is continuous, 24 hours outflow, 24 hours demand, we used the percentage consumption, but inflow is calculated by 320 million liter in one day. This is the total demand, total supply to be made in balancing reservoir. 320 divided by 24 into 2, divided by 24 into 5, 320 divided by 5, 24 into 5, 24 into 2. But here, the total 320 million liter in one day into 25% means 320 into 0.25. But here, 320 divided by 4 into 2, 320 divided by 4 into 0, 0, 320 divided by 4 into 1, 80. Again, cumulative inflow and cumulative outflow are calculated, and the maximum deficit is 133.338, and the maximum surplus, cumulative surplus is 0, as finally this 320 and 320 becomes equal and 0 in this step. Here are all deficit. 26 is less than 160, 93 is less than 160, 159 less than 240, 186 less than 320. So all are deficit, and here is 0.008 deficit. Nearly it is the neutral value. But the maximum value of the deficit, cumulative deficit, is 133.338. So the value of the volume or capacity of the reservoir is 133.338. Again, in this question, supply is done for intermittently, that is demand is continuous type, 25%, 30%, 15% same, that is 320, 25%, 320 into 0.25, 80, 320 into 0.3 means 96, 320 0.2 is 64, 320 into 0.1 is 32. Again same calculation, but in inflow it is only 12-hour inflow is given, that is 320 divided by 12 into 2, 320 divided by 12 into 3, 320 divided by 12 into 1, 320 divided by 2 into divided by 12 into 2, 320 divided by 4 into 2. That is 320 divided by 12 into 4, 3, 3, 1 is 3, 3, 6, 18. I calculate, okay. 320 divided by 12 into 4 is equal to 106.668. Okay. Here calculated inflows and outflow is same as question number 1, and the cumulative inflow, cumulative outflow, and maximum peak cumulative deficit is 74.664, cumulative surplus is 0.004, 74.664 plus 0.004 is the capacity of the balancing reservoir. In this last question, you can see that the 2 million have water 160 lpcd, so 2 into 160, 320 lpcd, 320 liter per day. Okay, but I have Kathmandu Valley as a population of like this, and the consumption. The when supply is done for 12 hours, supply is 12 hours, 4 to 10 in the morning, 4 to 10 in the morning. This is 5 to 7 2 hours, and 16 to 22, 16 to 22, 16 to 22 means 16 to 17 1 hour inflow supply, 16 to 22, 17 to 19, 2 hour, and 19 to 5 means 4 to 10 hour, 1 hour is here remaining. So 19 to 5 is other remaining 4 hour, total 12 hour you can see. And outflow is 5 to 7 in the morning, demand is 5 to 7, 5 to 7 2 hour, and 16 to 18, 16 to 18 here 1 hour and here 1 hour. Okay, and here both the supply and demand is intermittent type. So for the calculation, we use 320 divided by 4 into 2 is 160. 320 divided by 4 into 1 equals to 80. Similarly here, 320 divided by 12 into 2 equals to 53. 320 divided by 4 divided by 12 into 4, 106.668. Already same calculation. Again, maximum cumulative inflow, cumulative outflow. Cumulative inflow minus cumulative outflow is cumulative deficit if negative. 53 minus 160 negative 106.67 deficit, cumulative deficit. 133.160 is also negative. 160 minus 240 negative. 213 minus 320 is again negative. So the total capacity of the balancing reserve is the maximum cumulative deficit means 106.666 plus 0.004. Likewise, we can calculate all the problems of the balancing reservoir or the our impounded reservoir, service reservoir. Likewise, by using the analytical method means by using the formulas, that is summation of deficit or maximum cumulative deficit plus maximum cumulative surplus, and another is graphical method means mass curve method. If you like this video, you can subscribe my channel. Thank you guys.